Hyperbolas day 1. So we have two kinds of hyperbolas. We have vertical, which means it opens up or down, or we have a horizontal, which means it opens left and right. So hyperbolas have two branches, and they start at the vertices, or the vertex of each of the parabola. So we have, so here are the vertices for vertical, and so the major axis is always going to be the one that has the vertices on it. And this is what the shape of a vertical hyperbola would look like. And for horizontal, the vertices are going to be here and here. And again, our graph follows along our asymptotes going this way. Now that rectangular box is not normally there, but we use that to kind of help us figure out where our asymptotes are and how to graph these. So we're going to do that on the next page. So here again is your vertical hyperbola and horizontal hyperbola. The standard form for a vertical hyperbola is y minus k squared over a squared minus x minus h squared over b squared equals 1. Notice that the minus is in front of the x here. That's what makes this a vertical hyperbola. So if we changed our equation around and made it, instead of the x being the subtracted one, the y, then that gives us a horizontal hyperbola. So this one is going to be x minus h squared over a squared minus now y minus k squared over b squared is equal to 1. So just like ellipses, we have our equations are equal to 1. The center of our equations is always going to be h comma k, just like for circles and ellipses. So notice that a value, which is either underneath the y if we're vertical or x if we're horizontal, is always the distance from the center to your vertices. And so you can see that is this distance here for the vertical and this distance here for the horizontal. So vertices only exist on the major axes. And then we also have the foci, which are two fixed points located inside the parabola. So you can see here and here would be our focal points, and we have here and here. So again, it's always on the inside of your hyperbolas. So C is the distance from the center to the focal points, so from here to here or from here to here. And so that distance is actually gotten by using the Pythagorean theorem. So c squared is actually equal to a squared plus b squared. So you might ask yourself, where does that come from? So I'm going to show you a short video to help explain that.
Here we have a hyperbola that opens vertically. In other words, its major axis is in the vertical. We know this because the foci are aligned vertically with each other. Now let's call the distance from the center to the endpoint of the major axis A. And our focal distance, the distance from the center to the focus, C. Let's draw a circle that has F1 and F2 as the endpoints of its diameter. From the endpoints of the major axis, go straight out. Where those lines hit the circle, go straight up and down. The vertices of the rectangle is created will help determine the asymptotes the hyperbola follows. Since the minor axis is on the x-axis in this case, we will label half the length of the minor axis the distance A. Make sure that you notice that, unlike ellipses, the major axis is not necessarily the longer one for hyperbolas. Now pause the video. Looking at the diagram here, what do you notice about the relationship between A, B, and C? You're right, it's the Pythagorean theorem.
So you can see it makes this right triangle, which is why we use the Pythagorean theorem in order to get our c value. And as you can see here, that's where that distance comes from. So if we move this b over here, then the distance of c would be this distance here. So not really drawn scale here, but you get the idea from the other video we just watched. So the asymptotes, keep in mind, notice that the asymptotes are always going to have the center of our hyperbolas. So for the asymptotes, it contains the center, which of course is h comma k, and it also has some kind of slope for the line. So if we look at the vertical hyperbola, notice that you're going up A and over B in order to get to this line here, and up A and over B to get to this line as well. So the slope of the asymptotes for both of these would be plus or minus A over B. For horizontal, you're going instead of up A, now we're going up B and over A, so the slope of the lines for these asymptotes would be m is equal to plus or minus B over A. So that means to write the equation of the line, which contains, we know the slope, and it contains the point of the center, h comma k, and so we can use point slope form. So in this case, we have point slope form, y minus y1 equals the slope, m, times x minus x1. And so if we are looking at the one above, which is horizontal, we're going to use the slope being plus or minus b over a. So in this case, y minus, and our y1 is the k value, so y minus k equals our slope, which is plus or minus, again, b over a times x minus h. That gives the equation for the horizontal hyperbolas asymptotes. So similarly for the vertical one, instead of using the slope being equal to plus or minus b over a, we're going to use the center again, so h comma k, and we're going to use now the slope because we know this one for the asymptotes is up a over b, so plus or minus a over b. So we're using our point slope form, y minus k equals plus or minus a over b times x minus h. And again, that gives us the equation for the asymptotes. So it's going to go ahead and put this all together. So again, our general equation we have for opening left or right when you have the minus in front of the y term, and when the minus in front of the x term, you know it's going to open up or down and be vertical. And again, we know that similar to the ellipse, it must be equal to 1. So be careful, the equation, because it is so similar, the only difference is the fact that the signs are separating the two. So make sure you watch your signs in your equations. And so we've already said this before, that the center is HK. A is the distance from the center to the vertices. B is the distance from the center opposite direction of A. C is the distance from the center to your foci. And again, the vertices are the start of the parabola, and we know to get the foci, it's going to be using the Pythagorean relationship, c squared equals a squared plus b squared. How do you know which direction to move? Always look at your numerator. So when you're doing horizontal, A is underneath the X, B is underneath the Y. So that tells you the distance to move. And then it changes when we are doing our vertical hyperbola. So keep that in mind when you are graphing these, which we're going to do next. So when we're graphing, if you need to complete the square, for these we don't need to. We're going to locate the center. We're going to go A and B units in the appropriate directions, looking at the numerator to help us determine. Sketch a rectangle using marks of A and B from step 3 as the guidelines. We're going to draw the diagonals because those are the asymptotes, and then sketch the hyperbola and calculate, graph, and label the foci. So looking at this first one here, notice that this equation, the minus is in front of the y. For this one over here, the minus is in front of the x. And so remember, that tells us then that the direction of this opening is going to be horizontal. So the direction opens is left or right. And for this one, this is going to be a vertical hyperbola, and it's going to open up and down. So a in this case is underneath the x, so the square root, a is equal to the square root of 16, because remember that this is a squared, so that gives us 4. Underneath the y is going to be the square root of, or is b squared, so the square root of 25 gives us b, which is 5. And the center, we know that this is h and this is k, so that gives us our center being at -2, comma 1, because remember that it's always x minus h and y minus k, so to get that plus for the x, or the h, I should say, that's why it's negative. So now we can go ahead and plot the center. So I'm going to go -2 up 1. So there's my center. And then for the distance of the x direction, because the 16 is underneath of that, we know we're going to go left and right 4. So 1, 2, 3, 4. And 1, 2, 3, 4. That gives us our vertices. So we could go ahead and write those down as well. So we know our vertices are at 2, 1, and also at -6, 1. And now to help us get that rectangular box, which helps us get our asymptotes, we're going to go the distance of y using our b value, which is 5. So we're going to go up 1, 2, 3, 4, 5 from the center, and down 1, 2, 3, 4, oops, 1, 2, 3, 4, 5. Oops, one off. And so now that enables us to make that rectangular box, which is not really there, but it helps us graph our asymptotes. And so that's a rectangular box. So we know that our asymptotes are going to be the line that contains the corner of this rectangular box, and it also goes through the center. So now I just drew my asymptotes on my graph. So again, notice it goes through the corners of your rectangular box and through the center. And now I can go ahead and draw the hyperbola. So remember that this is horizontal, so that means we open left and right. And again, our parabola shape is going to follow our asymptotes, but not cross or touch over. And same thing on this side. And the next thing I need to do is figure out what my distance of C is so I can actually graph my foci on it. So remember that we said before, C squared is equal to A squared plus B squared. So in this case, C squared is equal to A squared, which we know is 16, plus B squared, which we know is 25. So C squared equals 41. So C is equal to plus or minus the square root of 41. And remember, that means we're moving from the center the distance of root 41, which is about 6.4 if you find the decimal. So I'm going to go ahead and use blue for this one. So we're going to go from the center 1, 2, 3, 4, 5, 6.4. And from the center left 1, 2, 3, 4, 5, 6.4. And again, your foci should always be on the inside of your hyperbolas. And so that gives us that. And so to write the actual equations, notice that from the center, we moved only the x coordinate, the y coordinate stayed the same. So this was, oops, plus or minus root 41. And to actually write the equations for the foci, it would be -2 plus or minus root 41, because again, we went from the center, left and right, root 41, comma, and the y coordinate stayed the same at 1. And that's it for our horizontal graph. So let's go ahead and look at the vertical one. So we're going to do the same thing. So for the vertical one, if I look at the equation, the 4 is underneath the y now, so that means that's the a squared. So a is equal to the square root of 4, which is in this case 2. And b is going to squares underneath the x, so the square root of 9, which gives us 3. The center, remember that is still always h is with the x coordinate and k is always with the y. So now our center is going to be 3 comma -2. And we're going to go ahead and use that to help us plot. So over 1, 2, 3, down 2. And then I'm going to go the distance of A, which was underneath the y coordinate. So we're going to go up and down 2. And remember, these are the vertices or the vertex of your parabolas, or where the parabola starts, I should say. It's a hyperbola. And then for this, we're going to go right 1, 2, 3, because that's the b distance, and left 1, 2, 3 from the center. And that gives us the rectangular box. And from there, we can graph our asymptotes. Now we have our asymptotes on our graph, and we can find our vertices again here and here. So our vertices we can see are at 3, 0 and 3, -4. And again, this is a opening up and down, so following your asymptotes from your vertices. And then we know that the foci are going to be on the inside of the hyperbola. So we again know c squared equals a squared plus b squared. So in this case, c squared is equal to 4 plus 9, which gives us c squared being equal to 13. So c is equal to plus or minus the square root of 13. And the decimal of that is about 3.6. So from the center, we're going to go up 1, 2, 3.6. And from the center down 1, 2, 3.6. Those are our foci. Notice that now, instead of changing like we did over here, the x-coordinate of the center, we changed the y-coordinate of the center. So the foci would be the same x-coordinate from the center, so 3, comma, and we took -2 and added and subtracted root 13. So those are coordinates for the foci. And so that's how we graph our hyperbolas. And if we wanted to actually write the equation for our asymptotes, we could. So remember, we use the slope and the point, which is the center, in order to do that. So let's go ahead and practice that for the first graph that we did here. So again, rise over run. So we know we're going up and over to get here. So we went up 5 and over 4. So I have a positive slope going 5/4 and a negative sloping line going 5/4. And we said the center we know was at -2, 1 from above, and the slope is plus or minus 5/4. And so the equation for the asymptotes would be using our point slope form. So y minus 1 equals plus or minus, or 5/4, because that's our slope, times x minus -2, so x plus 2. And if I wanted to do the same thing over here, now my slope for my asymptotes would be up 2 and over 3. So that means this line has a slope of plus or minus 2/3, and this line has a slope, or sorry, I should say positive 2/3, and the other way is -2/3. And so to write the asymptotes for this one, it would be y minus, the center was at 3, -2, so y minus -2 would be y plus 2 is equal to the slope, so plus or minus 2/3 times x minus, and the x coordinate was 3 for the center. And that gives us the equation of our asymptotes. And so that's all you need to know for your hyperbolas for now. And then tomorrow we'll talk about when you have to complete the square.